This is question number 5 from the 4.5 MyLab math homework on absolute maximums and absolute minimums. And in this problem, we're being asked to find the absolute maximum and the absolute minimum of this quadratic function. It's a polynomial, so it's continuous everywhere, over a closed interval. Now, whenever we're looking at a continuous function over a closed interval, we are guaranteed to have an absolute max and an absolute min. Either at one of the endpoints on the interval, so either where x is equal to -2 or x is equal to +4 in this case, or at a critical point. Now the critical point, remember, that's when you set your first derivative equal either to 0 or to undefined. But in this case, our function is a polynomial. It's continuous everywhere. It's quadratic. It'll never be undefined. So let's go ahead and find the critical point. I'm just going to take the derivative of my function using my power rule, and then I'm going to set that equal to 0. And when I do that, let's see what we get. Boom. 2x is equal to 4, so x is going to be 2. I have to ask myself, is this critical value in the closed interval? Is 2 in the domain -2 to 4? It is, so it's a contender. So we just plug those endpoints and that critical value back into the original function. That original function tells me the points on the graph, the inputs and outputs of the function. So when I do that, I have these 3 outputs, and I just have to see, okay, which one is the highest? That'll be my absolute max, and which one is the lowest? That'll be my absolute min. So the largest output is 3. So there's an absolute maximum of 3 that occurs at x equals -2. And then when I look for my lowest output, it's -13. So the absolute minimum of this function is -13 over this interval, right, from -2 to 4. The absolute minimum is -13, and that occurs when x equals 2. So that answers the question. I'm just going to demonstrate this on Desmos real quick, just for teaching purposes. Now, you're not allowed to use Desmos on test 3, but let's graph this function on Desmos and restrict the domain and see what's going on. Let's just check our answer that way, right? So I have our function graphed here. Now I can't see everything, so I'm going to have to do some restrictions. I'm going to restrict my domain from -2 to 4. So that was my given, was that it? -2 to 4? -2 to 4. Okay, cool. So I've restricted my domain. And let me zoom out a little bit. Then I can see right here. Okay, so that's the part of the graph I'm looking at. It's like I've cropped it or I've zoomed in. And then I can see that my largest output is up here when x was -1. I had a height of 3 on my graph, and I'm just going to confirm that real quick. When f was, sorry, not -1, -2. No, maybe I should come over here. Let's take our minor grid lines off. Let's count by 1 so I won't mess that up. There we go. Now I can see it's -2. So let's plug -2 into the function. Oh, it's undefined because I forgot to put greater than or equal to signs. Well, here we go. I didn't include the -2 and I didn't include the 4. And coming back here, we add brackets. It's a closed interval, so I need to include -2. X can actually be -2, and I need to include +4 because x can actually be +4. So I need to use less than or equal to signs there when I was doing Desmos. Okay, and then when I plug -2 into my function, it had a height of 3. Then I can do that critical value there. So the critical value was happening when x was 2. Let's plug that one, f of 2. That was my -13, and then -2. Sorry, +4. I've already done -2. Okay, that was a -9, and we can see that here on my graph. I'll even go back and make those ordered pairs so we can see them a little bit better. When x was -2, my output is 2, and I'll label that on my graph. Okay. When f was +2, the output of the function when f was 2. And then here, when x was 4, the output of the function when x was 4, and label that. Okay, so we can see those 3 contenders there marked on our graph. There's our critical point down here. I can see the tangent line went horizontal, so I know the derivative hit 0 there. Yeah, and from those 3 points, the absolute highest point was at the end point, and the absolute lowest point happened to be at that critical value. And again, no Desmos allowed on test 3, no graphing calculators allowed on test 3, but it's a really great teaching tool to help you really absorb the ideas, to play around a little bit with the functions. I could even plug in here to confirm that was, I could do f prime of 2 and get that 0 derivative out there so we can see, confirm that that was a critical value there when x equals 2, because the derivative at x equals 2 is 0. There's a lot you can do on Desmos just to kind of play around with the features. But yeah, so remember, in a closed interval, you're guaranteed to have an absolute minimum and an absolute maximum as long as that function is continuous over that interval. And you're only going to zoom in or consider those critical values and the endpoints.